All right, so this is the second target question in the week 6 math counts handout, and it says, the three-dimensional figure shown is a right rectangular prism. What's the area of triangle PQR, which it shows in the figure that PQR are those vertices of that right rectangular prism. So a right rectangular prism is a rectangular prism except the base is a square. So that's what we have here. We have two side lengths of 6 right here. And then our third side length, our third dimension, is going to be 8. So the first thing we should do is we should find the lengths of PQ, PR, and QR. Now, how do we do that? Well, to find the length of PQ, we know that this length right here is going to be the same as this length right here, which is going to be the same length as that right there, because this is a rectangular prism. So that's a 6, which means that this length must also be 6. So PQ is just going to be the hypotenuse of a right triangle with side lengths of a beautiful right triangle with side lengths of 6 and 8. Now 3, 4, 5 is a special right triangle which you should memorize, and so if you scale that up you get that 6, 8, 10 is also a special right triangle, so the hypotenuse is 10. But you could also do that, of course, using Pythagorean theorem, but it's just definitely worth it to memorize. You know, these three numbers, they make a right triangle, because then you can do it fast. So PQ is 10. Now for PR, well, we know this length is the same as that length, which is the same as that length. So this length right there is equal to 6. PR, or this length right here, that's not PR, that length is equal to this length. So that's just 8. And so we're in the same situation with PR as we were for PQ. It's just the hypotenuse, wow. It's just the hypotenuse of a triangle with a side length of 8 and a side length of 6, PR, and again, that's just going to be 10. So PQ and PR are 10, and so we can sort of start to see our triangle taking shape now. It's got to be isosceles because we have two triangles two edges that are the same, PR and PQ. So what about RQ? Well, this right here we know it's the hypotenuse of a right triangle with two side lengths that are the same, two side lengths of 6 and 6. And now this is a special right triangle. This is a 45, 45, 90-degree triangle, an isosceles right triangle. So for two legs x, the hypotenuse is going to be x squared root 2 if the legs are the same. So knowing that, we can say that the hypotenuse of this is equal to 6 square root 2, which again you could also figure out using Pythagorean theorem, but you should just have this rule memorized as well for 45, 45, 90-degree triangles. Anyway, we have that PQR has side lengths of 10, 10, and 6 square root 2. And we know that the area of a triangle is found by using the formula A equals 1/2 times base times height. So we have the base, it's 6 square root 2, but we don't have the height. So how do we find that? Well, the height can be found, it's just by dropping an altitude from the vertex perpendicular to the base. Now, since this is isosceles, we know that if we were to drop a vertex right down the middle, it would be perpendicular to the base. It would be symmetrical. Pretend my drawing is symmetrical. It would cut that right in half, making two right triangles with bases of 3 square root 2 each and hypotenuses of 10. Now, we know by Pythagorean theorem is if that's x squared plus 3 square root 2 squared is equal to 10 squared. So we get that x squared is equal to 10 squared, which is 100, minus 3 square root 2 squared, which is 18, because 3 squared is 9, times 2 squared is 2, so 9 times 2 is 18, and this equals 82. So x, the altitude, has got to equal the square root of 82, which can't be simplified into any simpler radicals. So plugging this in, we get the area is 1/2 times our base of 6 square root 2 times our height of square root 82. But now, since there's a square root 2 in the base, we actually can simplify this radical a bit, because this is just the same thing as 1/2 times 6 square root 2 times square root 2 times square root 41. That's equivalent to square root 82. And then we know that square root 2 times square root 2 is 2, which cancels out with a 1/2, and we're left with our final answer is that the area of the triangle is 6 square root 41.